Students, welcome to s.mathguru classes. So our main discussion is recurrence relation, discrete mathematics, recurrence relation. After this we shall start generating function. Recurrence relation, the last video some solution given, and next we consider another solution, problem solution. So find the solution to the recurrence relation an equal to 6 an minus 1 minus 11 an minus 2 plus 6 an minus 3 with initial condition a not equal to 2, a1 equal to 5 and a2 equal to 15. These are condition given. Now last video we solved some problems. If the characteristic roots are r1, r2, then solution is an equal to alpha 1 r1 to the power n, alpha 2 r2 to the power n. These are solution. It was given if roots are r1, r2, r3, then solution will be an equal to alpha 1 r1 to the power n, alpha 2 r2 to the power n, alpha 3 r3 to the power n. This will be our solution if roots are unequal, r1, r2, r3, these are unequal roots, then we get this is the solution of the recurrence relation. Now we consider this problem solution. Let an equal to r to the power n be the solution of the recurrence of the recurrence relation an equal to 6 an minus 1 11 an minus 2 6 a n minus 3. If this is the solution of the recurrence relation then we get this satisfies this equation. For an we write r to the power n. This is a n minus 1, we write r to the power n minus 1. This is r to the power n minus 2, 6 r to the power n minus 3. We get this. Just replacing an and putting r to the power n. The power suffix is n, power is r to the power n. This is a n minus 1, then power is r n minus 1. n minus 2, r to the power n minus 2. n minus 3, r to the power n minus 3. Now we are dividing both sides by this factor. r to the power n by r to the power n minus 3, 6 r to the power n minus 1 by r to the power n minus 3, 11 r to the power n minus 2 by r to the power n minus 3 plus 6. We get this. And this will be r to the power n minus 3, r to the power n minus 1 minus n minus 3, r to the power n minus 2 minus n minus 3 plus 6. And this is r to the power n cancel cube. This is 3 minus 1 2, r to the power 1 plus 6. All of this taking in left hand side, r cube minus 6 r square plus 11 r minus 6 equal to 0. We are taking this r in left hand side, then we get this. Now this is cubic equation, then it has 3 roots. The roots will be r minus 1, r minus 2, r minus 3 equal to 0. Then obviously r equal to 1, r equal to 2, r equal to 3. It has 3 roots. Now this is cubic equation. I have written directly the answer because I know the answer. And if we get in your exam, suppose this problem is given, how could we know this solution is roots are 1, 2, 3? Now it has a technique from lower class, you know, factor theorem. At that time we consider in this way. Let fr equal to this is r cube minus 6r square plus 11r minus 6. We consider this. Now the rule is that last term is minus 6, so this will be minus 6 equal to minus 1 into 6 minus 2 into 3 2 into minus 3. We putting these values, or we can write another one also, 1 into minus 6 also, 1 into minus 6. These are the factors. We putting this value one by one, ultimately we get 0. First we putting r equal to 1. If we putting r equal to 1, then 1 cube 6 1 square 11 into 1 minus 6, 1 minus 6 plus 11 minus 6, then we get 0. This is 0 means, therefore we get r minus 1 is a factor of fr. This is the factor of fr. That means if we divide fr by r minus 1, remainder will be 0. Fr means r cube minus 6r square plus 11r minus 6. Then we give r square, then this and this r cube, this is minus r square, this is plus, this is 5r square plus 11r minus 6. Give minus 5r, then 5. This is, if we give 5r, so here r cube now we give 5r, multiplying this 5r square plus 5r, this one 6r minus 6, then 6r minus 6, remainder 0. So we get this equal to r cube minus 6r square plus 11r minus 6 equal to 0. This means r minus 1 into r square minus 5r plus 6 equal to 0. That means we know dividend equal to divisor into quotient plus remainder. That means this into this, we get this dividend. And this is r minus 1. And if we factorize this, we get r minus 2, r minus 3, this equal to 0. So if we are unable to factorize this, then using this method, lower class method, factor theorem, for what values we get 0. If it is 0, then for putting 1 we get 0, then here we write r minus 1. If we putting minus 1 then 0, then we write r plus 1. Opposite. Plus 1 putting we get 0. So for this we solve this in this way. So 1, then 0, then we write minus 1. If it is minus 1, here we write plus 1. And we divide this, ultimately remainder will be 0. And dividend equal divisor into quotient plus remainder, then after factors we get this. I have written here directly this result because I know the result. So for this we get roots are this r equal to 1, 2, 3. All of these are unequal. If roots are unequal, then solution will be an equal to alpha 1 into 1 to the power n, alpha 2 into 2 to the power n, alpha 3 into 3 to the power n. This is number 1 you consider. This is the solution of the recurrence relation. An equal to alpha 1 1 to the power n, alpha 2 2 to the power n, alpha 3 3 to the power n. Now our initial condition given a naught. Now a naught, alpha 1 1 to the power 0, alpha 2 2 to the power 0, alpha 3 3 to the power 0. And the value of a naught is 2 given. So this is alpha 1, alpha 2, alpha 3, because something to the power 0 is 1. Therefore we get alpha 1 plus alpha 2 plus alpha 3 equal to 2. This is number 2 we consider. Next, A1, putting 1, A1 equal to alpha 1, 1 to the power 1, alpha 2, 2 to the power 1, alpha 3, 3 to the power 1. A1 is 5, alpha 1, 2 alpha 2, 3 alpha 3. So this will be alpha 1 plus 2 alpha 2, 3 alpha 3 equal to 5. This is number 3 we get. Next we putting A2, here 2. This is A2 equal to alpha 1, 1 to the power 2, alpha 2, 2 to the power 2, alpha 3, 3 to the power 2. And the value of A2 is 15, alpha 1, 4 alpha 2, 9 alpha 3. This implies alpha 1 plus 4 alpha 2 plus 9 alpha 3 equal to 15. This is number 4 we get. Now here we have 3 variables, alpha 1, alpha 2, alpha 3, alpha 1, alpha 2, alpha 3, alpha 1, alpha 2, alpha 3. Now we remove one variable and we convert in 2 variables. Now this is alpha 1, if you subtract alpha 1, alpha 1 cancel, 2 minus 3. 2 minus 3 implies alpha 1 plus alpha 2 plus alpha 3 minus alpha 1 minus 2 alpha 2 minus 3 alpha 3 equal to right hand side. This is 2, this is 5. 2 minus 5. And alpha 1 alpha cancel, minus alpha 2 minus 2 alpha 3 equal to minus 3. And multiplying by minus alpha 2, 2 alpha 3 equal to 3. This is number 5 we consider. Just subtract this minus this, alpha 1 alpha 1 cancel, this minus alpha 2, this minus 2 alpha 3, this minus 3, multiplying by minus, then we get this. Next 3 minus 4 implies 3 minus 4. This is 3 alpha 1, 2 alpha 2, 3 alpha 3 minus alpha 1 minus 4 alpha 2 minus 9 alpha 3 equal to 5 minus 15. 5 minus 15. Alpha 1 alpha 1 cancel. This minus 2 alpha 2 minus 6 alpha 3 minus 10. Dividing by minus 2, then alpha 2 plus 3 alpha 3. This is 5. So if we dividing both sides by minus 2, then we get this one. Now this is number 6. Now 5 minus 6 implies, then alpha 2 cancel, this minus alpha 3, this is minus 2. Then we get alpha 3 equal to 2. And putting the value of alpha 3 in equation number 5 implies alpha 2 into alpha 3 2, this is 3, alpha 2 equal to 3 minus 4, this is minus 1. Next we find alpha 1. Putting equation number 2. Now we putting the values of alpha 2 and alpha 3 in equation number 2. 2 implies alpha 1. Alpha 2 is minus 1, alpha 3 is 2 equal to 2. This is 2. And 2 cancel, we get alpha 1 equal to 1. Therefore, alpha 1 equal to 1, alpha 2 equal to minus 1, alpha 3 equal to, we get 2. We putting this value in equation number 1. Now we putting this value in equation number 1. Now 1 implies in 1 a n equal to alpha 1 1 to the power n, alpha 2 2 to the power n, alpha 3 3 to the power n, and putting the respective values, a n alpha 1 is 1 into 1 to the power n, alpha 2 is minus 1 into 2 to the power n, and alpha 3 is 2 into 3 to the power n. So this implies a n equal to 1 minus 2 to the power n, 2 into 3 to the power n. This is the final answer of the given problem. 1 minus 2 to the power n, 2 into 3 to the power n. This is the complete solution of the given problem. If roots are unequal, we can solve in this way. So dear students, these are very simple problems, very easy, but most important for exam. If recurrence relation, generating function, these are given in your syllabus, any problems will come. So there are different methods. If roots are unequal, we can solve in this way. And next class, next video, we shall solve if roots are equal, how to solve the recurrence relation if we have equal roots. So thank you for watching the video.